Okay, so let's think about a question that sounds really simple, but it's actually kind of profound. How do you measure something you can't see, you can't touch, you can't even hold? Before we had clocks everywhere, how did we even start to get a handle on time itself? Well, the journey to figure that out begins with two ancient rivals, one born from pure light and the other from water.
You know, the answer wasn't just one single magic invention. Nope, it was more like a partnership, almost a competition between two brilliant ideas, each one using a totally different element. One found the secret in the super predictable movement of a shadow, and the other? It found it in the steady, patient flow of water.
So, let's meet the two heroes of our story. First up, you've got the sundial, the master of the day, which tracks the sun's silent march across the sky. And then you have its counterpart, the one for cloudy days and total darkness, the water clock, sometimes called a clepsydra, which measured time with that constant, patient drip, drip, drip of water.
All right, first, let's follow the shadow. I mean, a sundial seems so simple, right? It's just a stick in the ground. But its evolution is this amazing story of astronomical discovery, and it completely revolutionized how we even think about what a day is.
So, the earliest time-telling gadget we've ever found comes from ancient Egypt. And it was pretty straightforward. The length of the shadow told you the time. But its design tells us something really fascinating about how they viewed the day. They saw it as two totally separate parts, morning and afternoon. They actually had to pick the whole thing up and turn it around at midday.
And then, of course, the ancient Greeks got involved. As masters of geometry, they took the sundial and totally changed the rules. They brought in this idea of seasonal hours. They just took all the available daylight, no matter how much there was, and divided it into 12 equal parts. Now think about that. It means a summer hour was way longer than a winter hour. It seems kind of weird to us, for sure, but it was a system that was perfectly in sync with the natural rhythm of the seasons.
Then the Romans did what the Romans always did best. They scaled it up, and they scaled it down. For the public, they built this massive thing called the Solarium Augusti, using a 30-meter Egyptian obelisk for the gnomon. That's the pointy bit that casts the shadow. But for individuals, they made these clever little portable sundials, including one that was literally shaped like a ham. Yeah, it was probably a very witty status symbol for a rich guy.
But the sundial's single biggest leap forward, that came from brilliant scholars in the Islamic world. They needed really precise prayer times, and that drove them to figure out that if you tilted the gnomon to align perfectly with the Earth's axis, you could create something truly revolutionary: equal hours. For the first time ever, an hour wasn't some shifting, seasonal thing. It was a fixed mathematical constant. 24 equal slices of a day. This changes everything.
Okay, so that takes care of sunny days. But what happened when the sun went down, or when it was just hiding behind the clouds? For that, we have to turn to our second hero. Let's dive into the world of the water clock, the tech that truly conquered the darkness.
The water clock, which has this great nickname, the water thief, it just popped up all over the ancient world. And each culture adapted it for a totally different problem. In Egypt, priests used it to time sacred rituals that had to happen at night. In Persia, it was a crucial economic tool for making sure everyone got their fair share of irrigation water. And in the law courts of Greece, it was a legal device, making sure lawyers couldn't just talk forever. And get this, it even led to what might be the world's very first alarm clock. The philosopher Plato, who apparently had a hard time getting his students to show up for their early lectures, reportedly rigged a water clock so that when the water hit a certain level, it triggered a loud whistle. He had basically invented the snooze button's worst enemy.
But those early water clocks had a major problem. As the water level in the tank dropped, the water pressure dropped, so the flow slowed down. That made them pretty inaccurate. The genius solution came from this incredible inventor named Ctesibius. He created an intermediate chamber with an overflow pipe. This kept the water pressure perfectly constant, which meant the clock ticked at a perfectly steady rate. This was a huge idea. It's the first known self-regulating machine in history.
This constant flow was a total game changer. Ctesibius could now use that steady rising water to actually power gears, which translated that linear motion into rotary motion. And this didn't just move a pointer on a dial.
It could run little automated figures or automata that would move and ring bells and all sorts of things. The water clock wasn't just a clock anymore. It was an engine.
This technology reached its absolute pinnacle in Song Dynasty China. A brilliant polymath named Su Song built this cosmic engine, an astronomical clock tower that was a staggering 40 feet high. It wasn't just telling you the time, it was a powered, working model of the entire universe as they knew it.
And the secret sauce inside this cosmic engine was a device called a hydromechanical escapement. Okay, so picture this, a giant water wheel with scoops on it. Water fills one scoop at a time. When it's full, its weight trips a lever, which lets the whole wheel turn by just one single position before another lock stops it again. Tick, tock. That precise start-stop mechanism for controlling power, that is the direct mechanical ancestor of the escapement in every single mechanical clock that would come later.
So we've been following these two incredible parallel histories, right? The shadow and the flow. But they don't stay separate. And the moment they converge, that's what gives us the modern world of timekeeping.
So let's just put them right next to each other. On one side, you have the sundial's dead-on astronomical accuracy. On the other, the water clock's ability to run 24/7. But the most important part, the real takeaway, is on that bottom line. The sundial gave us the concept of equal hours, but the water clock gave us the mechanism of automation. So think of the sundial's contribution as the software. It's the abstract mathematical framework of 24 equal unchanging hours. It is literally the operating system for modern time.
And the water clock? Well, that provided the hardware, the gears, the feedback loops, and most critically, that escapement mechanism you need to physically control power and make a regular, steady tick.
And when you finally marry the sundial's abstract software with the water clock's physical hardware, what do you get? Boom! The mechanical clock. It is the direct child of this ancient partnership and is the invention that would, no joke, change the entire world.
And this connection wasn't just a nice idea, it was real. For centuries, the first mechanical clocks were, let's be honest, pretty terrible. They were notoriously unreliable. So how did people set the correct time on them? You guessed it, they used a precision sundial. The old master technology served as the gold standard to calibrate its own replacement.
So why does all this ancient history really matter to us today? Because the ideas born from that shadow and that flow literally built the world we all live in.
I mean, that shift from time as a subjective feeling to something you could actually count, that was the bedrock for all of quantitative science. And the legacy is shockingly direct. NASA's Mars rovers, they still use a sundial to calibrate their cameras. And in Iran, some of those Persian water clocks were used for irrigation right up until 1965. That's a continuous run of over 2,000 years.
There's this beautiful motto you can often find inscribed on old sundials. It says, "I count only the sunny hours." It's just a poetic reminder of where this whole story started. These incredible instruments, they taught us how to slice and dice time into ever smaller, more precise units. But it kind of leaves you with the question, doesn't it? In our world of nanoseconds and clocks that never stop, have we forgotten how to count only the sunny hours?